Astrophysicists are trying to figure out what destroys entire galaxies in the most extreme regions of the universe. Scientists at the International Centre for Radio Astronomy Research in Australia have studied more than 110 galaxies and concluded that their gas and dust are being stripped away. Without this building material, galaxies stop forming new stars, and the old ones eventually fade away. So what's causing galaxies to be eaten up by some unknown galactic monster? And what cosmic anomalies still defy explanation? One idea is that this is caused by the increasing expansion of our universe. So speed may just be as dangerous in space as it is on the road. When galaxies start moving too fast in their cluster, storms can arise within them, capable of rapidly pushing gas out of galaxies. But there are other possible ideas. Black holes are thought to be located at the center of most galaxies, and because of the strong radiation of matter inside these black holes, powerful particle streams burst out of them. These cosmic jets can blow everything out of a galaxy. Another possibility is that galaxies are digging their own graves. They start burning up stars much faster than their neighbors and don't have time to recover their gas reserves. This leads to their slow extinction, which scientists call strangulation. Whatever the reason behind this mass destruction is, scientists struggle to understand the existence of some galaxies. These are red-hot Jupiters, huge gas planets similar to our Jupiter that orbit in the arms of their stars. And scientists don't understand how it's possible for their existence in the first place. But there are three hypotheses. The magnetic field of a parent star could be a protective barrier for a gas giant, or the red line for a planet is its dust disk. A gap is formed between the inner edge of such a disk and a star, neutralizing the attraction of that star. Alternatively, a planet's approach to a star stops when the elongated orbit of a hot Jupiter transforms into a circular orbit. While scientists look for evidence to back up their theories, giant worlds keep surprising researchers. Take WASP-121b in the constellation Puppets. For example, lying 850 light-years away from Earth, the planet is 174 times the radius of Jupiter and 1,157 times its mass. The giant rotates so close to its star that it makes an orbit around it in just 30 hours. That's 68 times faster than Mercury rotates around the Sun. Particles of molten iron, magnesium, chromium, vanadium, aluminum, and titanium create clouds on the cooler hemisphere of WASP-121b. There, aluminium condenses with oxygen and together with admixtures of chromium, iron, titanium, or vanadium, its droplets form either rubies or sapphires, which might fall like rain on the planet. However, no alien life would be able to make use of these gems because of the proximity to its star. WASP-121b is about 2,700 degrees Celsius, making the existence of protein life there impossible. Although the majority of objects in the universe come to an end in a quiet extinction, some of them stop existing in a more impressive manner. Back in 1967, the Velo satellite designed to monitor secret Soviet nuclear tests detected a blinding flash of gamma rays outside the solar system. Gamma rays are a very powerful kind of electromagnetic radiation, and astronomers observe approximately 1 gamma ray burst per day in distant galaxies. These flashes in space happened as a result of some of the strongest and brightest explosions in the universe. Their duration can range from 10 milliseconds to several hours. When something like this happens, sometimes the amount of energy released is about as much as our sun radiates. In 10 billion years, astronomers were able to identify stars that turn everything around them to dust. During such events, prolonged gamma ray bursts occurred during hypernovae or the death of a star with more than 30 solar masses. Sometimes an explosion can be 100 times more powerful than a conventional supernova, and these dead stars leave behind giant, rotating black holes. Short-lived gamma-ray bursts are also believed to be caused by neutron stars. As a result of a ripple in space, a neutron star can collide with another neutron star or be swallowed by a black hole. The nature of such events is still not fully understood. Recent observations have shown that after gamma-ray bursts take place, all photons travel in the same direction. Then suddenly, at some point in space, they inexplicably change their path. It's also strange that gamma-ray bursts have energy focused in a narrow beam, so our satellites don't see many of them. Astronomers estimate that there may be actually about 500 gamma-ray bursts happening every day. Scientists believe the LEGO Observatory Laser Interferometer Gravitational Wave Observatory, which is very sensitive to gravitational waves, will be able to record many more gamma-ray bursts. Let's hope that they don't find gamma-ray bursts anywhere near the Milky Way. Let's hope that they don't find gamma-ray bursts anywhere near the Milky Way. One of them was earlier observed near our galaxy about 450 million years ago, and it caused an ice age on Earth which ended with the Ordovician extinction, one of the 5 largest in the history of the planet. A new flash nearby Earth would presumably destroy the ozone layer of our planet. If this happens, all life will cease to exist as a result of the deadly ultraviolet radiation. However, because there are no neutron stars in the vicinity of the Milky Way as well as candidates for supernovae or hypernovae, scientists are confident that the probability of such an event is close to 0. There definitely will be other dangers discovered to our solar system and to our planet in the future, but for now, it doesn't look like we have anything to worry about except for the occasional asteroid that flies by our planet sometimes unexpectedly. Most galaxies are structured with filaments of gas and dust between stars, or a type of cosmic skeleton that appears to hold everything together. A few seconds after the Big Bang, dark matter and dark energy spread throughout space. A kind of web was formed, and dark matter seems to be responsible for the large-scale structure of the universe as we know it. But wait, what is this stuff we're talking about? Dark matter is thought to be a non-luminous material that makes up around 27% of the universe, and could take the shape of many different forms of particles, including weakly interacting particles or randomly moving high-energy particles. Dark energy, on the other hand, is an unknown form of energy thought to make up roughly 68% of the universe. Researchers found evidence of dark energy by measuring supernovas, which showed that the universe doesn't expand at a constant rate but is actually accelerating. In simpler terms, dark matter is like glue or cement that seems to be holding the universe and everything in it together. And dark energy is the force that's pulling on the universe in every direction and accelerating its expansion. So what's so special about this? Take a look at this image of the galaxy NGC 1052 DF2 from the constellation Cetus, which is located 62 million light-years away from Earth. At first glance, there's nothing special about the image, except this galaxy has many fewer stars than the Milky Way. But this isn't what really got scientists' attention. That galaxy, along with its neighbor galaxy NGC 1052 DF4, seems to be missing all dark matter. The largest map of the universe's dark matter was made by astronomers at the observatory in Chile and demonstrates this phenomenon. So why is there no dark matter in the galaxies from the constellation Cetus? And how do these two galaxies manage to survive and not fall apart? One suggestion is that larger, neighboring galaxies have stripped gas from galaxies DF2 and DF4. Now they are tearing apart their smaller neighbors. And in the latest study, cosmologists have suggested that about 8 billion years ago, two dwarf Galaxies collided with each other. That cosmic catastrophe resulted in a distribution of gas, which formed many new dwarf galaxies. Eventually, the two newborn galaxies didn't get dark matter, so they now have to survive without a skeleton. But this is not everything that has astronomers baffled. More than 400 exoplanets discovered by scientists shouldn't have survived either. We'd like to know what you think about the strange things happening in our universe, and let us know if we missed one. You might hear a suggestion in our next video. And to make sure you don't miss out on anything incredible happening in our universe, stay tuned here by subscribing. Thanks for watching.